metal ceilings must be bonded. NEC 250.118 states that exposed conductive surfaces within 6 feet, or 1.8 meters, of the edge of any tread, step-off, or landing of stairs or platforms shall be bonded to the grounding system. The rationale is that the metal ceilings are within 6 feet of the open ends of the wash bays. Personnel can access the attic through the access panel in the equipment room. Therefore, the metal ceilings need to be bonded to the grounding system to prevent electrical shock if someone touches both the ceiling and a grounded object, for example, a metal conduit or a concrete floor. The metal ceilings can be bonded to the grounding system using a bonding jumper. The jumper should be connected to the ceiling panels and to the nearest accessible ground point, for example, a ground rod or metal conduit. Bonding ensures electrical safety by creating a low impedance path for fault current to return to the source. This facilitates the operation of overcurrent protective devices like circuit breakers or fuses, which quickly de-energize the circuit and prevent electrical shock hazards. The National Electrical Code, or NEC, provides specific requirements for bonding to ensure that all conductive materials are properly connected to the grounding system. This includes metal conduits, enclosures, and other metallic parts that may become energized due to a fault. Effective bonding reduces the risk of voltage differences between conductive surfaces which can cause electric shock. In the context of a car wash, the presence of water and conductive materials increases the potential for electrical hazards. Therefore, bonding the metal ceilings is a crucial safety measure. Consider the specific requirements outlined in NEC 250.118. This section focuses on exposed conductive surfaces near stairs or platforms, highlighting the importance of bonding in areas where people may come into contact with grounded objects. The code mandates that these surfaces be connected to the grounding system to minimize the risk of electrical shock. The bonding jumper used to connect the metal ceilings to the grounding system should be sized appropriately based on the size of the ungrounded conductors supplying the electrical equipment in the car wash. NEC 250.102 provides guidance on the sizing of bonding jumpers, ensuring that they are capable of carrying the maximum fault current that may occur. It is important to select a bonding jumper that is made of a suitable material, such as copper or aluminum, and that is protected from corrosion. The jumper should be securely connected to the metal ceiling panels and to the nearest accessible ground point using approved connectors or methods. The ground point can be a ground rod, a metal conduit, or another component of the grounding system. The connection should be made in a way that ensures a reliable electrical path. When bonding metal ceilings, it is essential to consider the location of the equipment room and the accessibility of the attic. The presence of an access panel in the equipment room allows personnel to enter the attic and potentially come into contact with energized components. Therefore, bonding the metal ceilings in the equipment room is crucial to protect these individuals from electrical shock. The metal conduits that run through the attic and down the masonry walls to supply the self-serve controls and wall-mounted wall pack lights should also be properly grounded. This ensures that any fault current will be safely conducted back to the source, stripping the overcurrent protective devices. The grounding of the metal conduit should comply with NEC 250.100, which provides requirements for grounding metal enclosures and racewars. It is important to inspect the metal ceilings for any signs of damage or corrosion. Damaged or corroded ceiling panels may not provide a reliable electrical path, which can compromise the effectiveness of the bonding system. If any damage is found, the ceiling panels should be repaired or replaced. Regular inspections and maintenance of the bonding system are essential to ensure its continued effectiveness. This includes checking the tightness of the connections, inspecting the bonding jumpers for damage, and testing the continuity of the grounding path. Any issues that are identified should be promptly addressed to maintain the safety of the electrical system. Remember that the metal ceilings in the car wash are considered exposed conductive surfaces. This means that they are likely to become energized in the event of a fault. Bonding these surfaces to the grounding system provides a low impedance path for fault current to flow, which helps to quickly clear the fault and prevent electrical shock. In addition to bonding the metal ceilings, it is also important to ground all other metal parts of the car wash that are likely to become energized. This includes the metal frames of the self-serve controls, the wall-mounted wall pack lights, and any other metal equipment that is accessible to personnel. The grounding of these metal parts should comply with NEC 250.110, which provides requirements for grounding equipment likely to become energized. When installing the bonding jumpers, it is important to avoid creating ground loops. Ground loops can occur when there are multiple paths for ground current to flow, which can result in unwanted current circulating through the grounding system. This can cause noise and interference in electrical equipment, and it can also increase the risk of electrical shock. To avoid ground loops, it is important to ensure that there is only one path for ground current to flow from each metal part to the grounding system. This can be achieved by using a single bonding jumper to connect each metal part to the nearest accessible ground point. The NEC provides comprehensive guidelines for electrical safety, including requirements for bonding and grounding. It is important to consult the latest edition of the NEC and to follow all applicable requirements when designing, installing, and maintaining electrical systems. Proper bonding and grounding are essential for protecting people and property from electrical hazards. Neglecting these safety measures can result in serious injuries or fatalities. Therefore, it is crucial to prioritize electrical safety and to ensure that all electrical systems are installed and maintained in accordance with the NEC. Now, let's delve deeper into the specifics of NEC 250.118. This section of the code is particularly relevant to our scenario because it addresses exposed conductive surfaces within 6 feet of stairs or platforms. In a car wash environment, the open ends of the wash bays effectively function as platforms where individuals might stand or step off. Therefore, the metal ceilings within this 6-foot radius are subject to the bonding requirements of NEC 250.118. The purpose of this requirement is to minimize the potential for voltage differences between the metal ceiling and other grounded objects in the vicinity. If a fault were to occur, causing the metal ceiling to become energized, the bonding jumper would provide a low impedance path for the fault current to flow back to the source, tripping the overcurrent protective device and preventing a dangerous voltage build-up on the ceiling. Without proper bonding, a person touching the energized ceiling and a grounded object simultaneously could experience a severe electrical shock. Furthermore, consider the equipment room and its access to the attic. The presence of an access panel means that personnel could potentially enter the attic space and come into contact with the metal ceiling or other conductive materials. In this case, the metal ceiling in the equipment room must also be bonded to the grounding system, ensuring that it is at the same electrical potential as other grounded objects in the room and the attic. The bonding jumper should be sized based on the ampacity of the circuit feeding the equipment in the car wash. NEC 250.102 provides tables that specify the minimum size of the bonding jumper based on the size of the ungrounded conductors. It is essential to consult these tables to ensure that the bonding jumper is adequately sized to carry the maximum fault current that may occur. The bonding jumper should be installed in a neat and workmanlike manner with secure connections at both ends. The connections should be made using approved connectors or methods such as compression connectors or exothermic welding. It is important to avoid using methods that may loosen or corrode over time, such as wire nuts or tape. The bonding jumper should be protected from physical damage. If the jumper is exposed to potential damage, it should be enclosed in a conduit or other protective covering. It is also important to ensure that the bonding jumper is not subjected to excessive tension or stress, which could weaken the connection and compromise its effectiveness. In addition to the bonding jumper, it is also important to ensure that the metal conduits are properly grounded. NEC 250.100 provides requirements for grounding metal enclosures and raceways. The metal conduits should be grounded by connecting them to the equipment grounding conductor or to a grounded metal enclosure. The grounding connection should be made using approved connectors or methods. It is important to inspect the metal conduits for any signs of damage or corrosion. Damaged or corroded conduits may not provide a reliable electrical path, which can compromise the effectiveness of the grounding system. If any damage is found, the conduit should be repaired or replaced. Regular inspections and maintenance of the grounding system are essential to ensure its continued effectiveness. This includes checking the tightness of the connections, inspecting the grounding conductors and conduits for damage, and testing the continuity of the grounding path. Any issues that are identified should be promptly addressed to maintain the safety of the electrical system. The importance of following the NEC requirements for bonding and grounding cannot be overstated. These requirements are designed to protect people and property from electrical hazards. By adhering to these requirements, you can help to ensure the safety of the car wash and its occupants. Remember that electrical safety is a shared responsibility. Everyone involved in the design, installation, and maintenance of electrical systems should be knowledgeable about the NEC requirements and committed to following them. By working together, we can create a safer environment for everyone. The NEC is a living document that is constantly updated to reflect the latest advances in electrical technology and safety practices. It is important to stay up to date on the latest changes to the NEC and to ensure that your electrical systems comply with the current requirement. You can access the latest edition of the NEC through the National Fire Protection Association, or NFPA. The NFPA also offers a variety of training and certification programs for electricians and other electrical professionals. Taking these programs can help you to stay current on the latest electrical safety practices and to enhance your skills and knowledge. Electrical safety is not just a matter of compliance with the NEC. It is also a matter of common sense and good judgment. Always be aware of the potential hazards associated with electricity and take steps to minimize the risks. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. In summary, bonding the metal ceilings in the car wash is a critical safety measure that is required by the NEC. By following the NEC requirements for bonding and grounding, you can help to protect people and property from electrical hazards. Remember to consult the latest edition of the NEC and to work with a qualified electrician to ensure that your electrical systems are installed and maintained in accordance with the applicable requirements. Safety should always be the top priority when working with electricity.